Thank you very much. So we are waiting for two last speakers. Thank you very much. So I'm Olivier Stasse, and this robotic session has been organized with Nicolas Mansart, who unfortunately is in Finland. He got a fellowship to go there, and I think he's cold now. So what I will try to briefly do is, during 10 minutes, just briefly set up the kind of problems we are interested in and how it relates to ANITI. Then there will be a presentation by Shization from INRIA Willow, who will be the main speaker for 40 minutes, and there will be time for questions. Normally we have done this, and then it will be Armand, and then Alexandre, who is with me in the 3PO chair, and who will give us some insight about robotics at Airbus. So to go into the details, so what we're interested in, at least in my group and in the group of Ludovic Righetti, who was international chair, and where Nicolas Mansart is a copy high, we would like to build an intelligent robot. And what I put here is a proposal by Stanford and OpenVLA by one of the founder of physical intelligence, where basically you've got an image, you have a language instruction, put the eggplant in the bowl, and then those information are pre-treated by frozen models like Dino-V2 for the information, Siglip for the text. It goes through projector to do tokens, and you have the Llama tokenizer to ask the robot what should the robot do, and then from this you extract a token, which is then sent to an action day tokenizer, which is usually a diffusion process, which is doing an action on this small Ola robot. And so, well, it's interesting, but to be honest, for a roboticist, there's plenty of stuff which are missing, like how do you do visual feedback, all the process. There is lack of structure, and I think we will have some interesting insight from Chize and Armand on this. But what I will try to briefly tell you is what we think is working, and in the light of use case and requirements, which were actually done during an industrial panel with from companies. We had Schaeffler, the French National Railway, Renault, Airbus, Thales, Robotics Place, Safran gathering together and give us some insight of what they are expecting from us. So of course, what they would like to have is to be able to replace human on a repetitive task where you have, for example, musculoskeletal disorder. We would like to avoid them exposure to risks, like, for example, to go to inspecting railways in a very dangerous situation. When something that we found out very often, for example, for Airbus or manufacturing, is the flexibility and the agility. For example, you have customers asking you new batches of, for example, shell for a cell phone. You want to customize them for the anniversary of a company. Then you need this flexibility and this agility. And then the last very important point is compliance. There are new regulations, and you need to make sure that your robots are certifiable. Then in terms of features, they want to have speed, and you will see that it's difficult to get, especially with diffusion process. They are super, super slow, as I will show. In terms of imitation learning, what people would like to have is the fact that right now, if you want to have your robot doing a backflip, like the previous hydraulic humanoid robots, you need to have a PhD and 2 years of experience on the robot to be able to do that. Whereas what is here, what people would like to see, just natural interaction and having the robot performing the task. 3 other stuff, which are, for example, precise manipulation and dexterity. And believe me, with Airbus, it has been 10 years we have tried to drill holes with the level of quality requested by Airbus. We evaded. We went to something much more simple, and still right now, after 10 years, we are starting to reach this much more simple task. And of course, we want the robot to be autonomous. So something I'd like to point out is that a lot of people are talking about interaction with human. Due to the certification and compliance, this is extremely difficult. Most of the certification ask you to have a laser barrier and the robot being completely shut down when somebody is going from the robot. So we believe that autonomy is much more something that you would like to have. And then I was given this interesting picture where clearly there is plenty of problems. So for instance, you can see those robots, they have a large bases, and having a large footprint robot inside the factory is usually not something that you would like. Actually, specifically in classical robotics or factory, they want to have something much more thinner. And you see those robots actually, despite the fact that they have these large bases, they may fall. And then you need people like me who have studied balance for humanoid robots to make sure that those robots are not falling down. And actually, very often, it's due to the fact that those robots are not able to handle balance that they need to have a strong certification. So now, if you have a quick look at what you can get, you've got this video which has been released, I think, a few days or 1 week ago, of G1 robots assembling pieces that they actually used to build other G1. Maybe you didn't notice, but just at the beginning of the video, they were close to speed up for this kind of robot. And it might be, so still they are very capable in terms of unforeseen events, like somebody playing tricks on the robot. And here, the main part is this nice interface called the Unifying Manipulation interface, which are used to do a lot of diffusion processes. But the robot can be much, much faster when you are speaking about very quick motion, but not precise. So in terms of locomotion, it was really a revolution. On this, thanks to backdrivable actuator, and the main point of this Unitary is that they have a really low price, and the pace at which Unitary is improving the hardware is really, really amazing. Every 6 months we have a new robot being more capable, and this is something that needs money, and I'm glad to see that there are courageous entrepreneurs in France who are trying to build new hardware. Now, in terms of real application, I'd like to show you the Atlas humanoid robot. So here it's a bit unclear that it's imitation. Well, let's see what the robot is doing with this new space. And when you see this kind of motion, you can know that this is not imitation. Clearly, this is not, it's using optimization. So what we see right now is a mixture of classical control, very efficient, where you're trying to minimize a reward function, which is going straight to the point. And using, for instance, using vision to know where it is and adapt in real time the behavior of the robot here in proof of concept. This is not a real factory, but honestly, I bet this is that Boston Dynamics will be the first to showcase real first application, specifically in Hyundai in their mega factory. Where they have already introduced, for example, Spot for inspection tasks. The point is here, the high price, this is not clear if it's going to be viable from the business viewpoint. But in terms of capacity, it's probably the first robot that we will see doing amazing stuff. So what we have done in the share is, for example, working, thanks to Maciej, in the mixture of two reinforcement learning policy. So we learn separately walking and reaching. We were able to apply it to actually the H1 humanoid robot, not still on the real robot. It proved to be difficult in the fact that usually the initial approach was using GAN, and those GAN have collapse, a unimodal collapse. So we introduce a diffusion representation on the GAN, which allows us to have a multimodal representation of the two initial policy. So with the second one, using hierarchical reinforcement learning, we're able to mix those two with a very simple reward function. So I think we decrease the fact that the complexity of deploying this kind of behavior. And in terms of reinforcement learning, we try to compare classical MPC with reinforcement learning applied on a very unstable robot. So everything is open source. You can rebuild the robot, you can rebuild the power electronics. We also have the software which is open source. And all the benchmark, it's better than MPC. And we're able to apply the same algorithm on a small biped robot on the bottom. And it worked, so with 2 or 3 months of deployment. So we really think that now RL is a tool that can be deployed by a company very, very quickly. I think it's becoming nowadays standard knowledge if you have a good model of your robot. So I will now let the floor to Shizei Shen, who is an in-area researcher from Willow working with Cordelia Schmidt.